My name is Jeff Hartnett. I'm a mechanical design engineer here at Country Home Products, the home of DR Power. We are based in rural Vermont, and we design, manufacture, and sell outdoor power equipment. We focus more on unique needs that aren't filled in the market. We try to take innovative technology and innovative ideas and focus on those. We have six engineers on staff here. We have sort of two spheres of responsibility. One is developing new products, and that's what I'm personally involved in. And then we have what we call sustaining engineering, which is supporting existing products, reducing costs, reducing warranties or issues in the field, maybe making slight tweaks or improvements. We've got 6 different engineers, all maybe at various stages of a project, and EPDM has a nice workflow, so it's sort of standardized how we take care of all of the files and assemblies and drawings. It enforces revision control, so if we're really busy working on a project, and it kind of keeps us in line and keeps the documentation really clear, which is great for the sustaining engineers who have to go back and address problems later on down the line and work with vendors to address manufacturing issues and things like that. So EPDM's been great in that respect. The Kinetic Log Splitter is a pretty unique or innovative technology. It's the general idea is you have an engine or power source that spins the flywheel, generates a lot of rotational energy. Then we use a rack and pinion to translate that rotational energy into linear motion, and that basically pushes the log into a wedge to split the wood. So the main benefits of it are that it's much quicker than hydraulic, and you can split quite a bit more wood in the same amount of time. It's much more efficient, uses less gas. The latest addition to the lineup is the K22 log splitter. It's equivalent to a 22-ton hydraulic log splitter, and the idea was to take the technology that works really well on our larger K28 and K34 log splitters and scale it down to a more approachable price point. There's 2 models. There's a gas-powered model. It's a 100cc, 3.5 foot-pounds of torque gas engine, and then there's also an electric option, so electric motor-powered. There aren't very many electric-powered log splitters of this size. There are very small 5-ton electric log splitters, so those are more tabletop, more for splitting kindling and really small wood you might have in your house. This isn't very common, so it's yeah, it's nice you're able to use it indoors in a barn or underneath cover and still get the large splitting force. We used SolidWorks to design the entire machine. We modeled all of the parts and made all of the drawings that we used to manufacture it. It's very flexible. I mean, we can use it early in the process if we're just trying to come up with just a general idea, working on conceptual stuff. It's pretty easy and flexible to use there. And then it's great for getting into the details and building complex assemblies, using those to create drawings that we'll send to manufacturers. It's easy to convert file types for working with vendors, so that's great, and it's got a lot of flexibility with things like surfacing to make pretty complex shapes, and we'll work with industrial designers on the look of a machine, and having all the features and functionality that come with SolidWorks allow us to make things that they come up with. On the K22, we used simulation to design the plastic guards that go around the machine. They have some interesting shapes that we wanted to incorporate from an industrial design perspective, and then it also needed to be strong enough to pass relevant safety standards and make sure it was going to last as long as we needed it to, and keep it safe for the user. They're very large, about 3 feet by 3 feet. There's one on either side. Due to the material that we needed to use, rapid prototyping them would be very expensive and costly, especially if we needed to do multiple versions. So simulation helped us check multiple iterations of the design, add in features where we needed to quickly, and ensure those were going to work prior to spending a pretty large investment on tooling to make them. We would recommend SolidWorks to anybody doing mechanical design. It's got a tremendous amount of functionality to make complex parts and of any different manufacturer type. Simulation's a great tool. It integrates seamlessly into SolidWorks, and you can do quick analysis, which is critical for us on our short product development cycles. Working with CAPINC has been great. I've used them personally quite a bit for technical support. anytime I'm having an issue, just pick up the phone and get great response from the technical support folks. I've taken a couple classes. Their advanced surfacing class was really helpful in getting a better understanding and using that tool a bit more. So just kind of building confidence with it.